Okay, I think the recording has started. Thank you everyone for joining us today. I believe you all can hear me, right? If you cannot, I believe I'm audible enough, right? If I'm not, let me know.
Yes, you are.
Okay,
Yes, sir,
so
you're audible enough.
our recording has started. Thank God we are in sync. So today we are going to be talking about introduction to programming, and as I was saying before, we're going to have two classes actually. We are going to have the theory part of programming, and then hopefully we should be able to finish what we have today, so that next class we'll do more of talking, answering questions, and then practice. But it's advised that after this class you go on your own and practice what you've learned, research more, try to understand. If you have any question, drop it on the WhatsApp and the Telegram group. Someone will respond to you, or you can chat me up, or I don't know, but just drop your message there, drop your questions there. Definitely someone will respond. So if I don't respond, someone will definitely respond to you. So I'm really happy that some people are really engaging other people in the group, and it is really an interesting thing. So if we encounter any problem, nobody is an island. We are here to learn. So if your neighbor or someone knows it better than you, or you're doing it wrongly and someone is there to correct you, it's fine. It's also encouraged. The person can help you so you can do better. So like I said, it's going to be two classes, the theory part and then we'll do the practical. So the theory part is just for us to understand the theory behind programming, the terms that we may likely be encountering in the field, in this industry called programming, and so you don't get lost when we use those terms. And then this is what I'm giving you guys now is more like computer science 101. So just stay tuned and then pay close attention, and I believe you will learn. Then when this first section ends, when we go over to the next section, if we still have time, we'll still do a little bit of practical. We'll go into in depth of what we have today, but I pray we're able to finish what we have. So let's just get straight to it. I'll be sharing my screen in a bit. Screen record I'm using here. Don't really like it, but it's fine though. Okay. Can you all see my screen? Okay. Okay. So we'll be going over talking about introduction to programming. So today, please, it's advised you join this meeting. Okay, you can join whatever device you're using now, but in the next class that will be actually writing some code, it's good you join the next class with your laptop. If your laptop is up, you better, as we are learning, try to set it up so that when we go over to the next section, you won't be lost. You can actually join and practice what I'm going to be showing you. So what is programming? I asked this question in test. Some of us were not answering it correctly. But programming is just an act or a process of writing instructions for a computer to perform a specific task. Programming is used to create software, websites, and apps, whether desktop app or mobile application. To program, you need to learn a programming language, and there are many different programming languages, each with its own strengths and weaknesses. Some popular programming languages include Python, Java, C++, and JavaScript. Once you have learned a programming language, you can start writing programs. Okay. Now, programming is the act of writing a program. That's the core definition of program. Programming is the act. Remember, programming is the act of giving instruction to computer. You understand? It's the process of giving instruction to computer for computer to perform a task. But the act itself, the ability for someone to come up and think about how to create it, You understand? The act is the programming, but the programming itself is the act of writing computer program, which is, don't get it twisted, I know why I'm going towards this route. So the key point I want to highlight here is program. Program are those instructions that you are going to give to computer. It is generally called a program. Now, a program is made up of instructions, and these instructions are sometimes called statements. Then what is a statement? A statement is a single line of code dedicated to doing a specific thing. You understand? Note the word single line is a single line of code. In a code block now, you can have thousands of lines of code. Codes are executed line by line in a sequential order from the first to the second to the last. So each line is assumed to be a statement. So a statement is a single line of code dedicated to do a particular thing. Now, you can have a line of code that says, I give an example here, let A equal to 2. This is a statement, and the statement simply says create a variable called A and assign it to a value of 2. Do you understand? It's as simple as that. Now, programs are executed in sequential order. I've mentioned that statement by statement, one after the other. Now, statements are in a program can be organized into groups of, like, you can say, okay, we have a specific task we want the computer to handle, but we need to write some logic for it to happen. So we now wrote different lines of code, but want to group them so that they can be organized in a certain manner. Now, they're trying to tell us here that statements in a program can be organized into groups to perform a particular task. These groups of organized statements are called functions, right? I believe that's clear. So what is a function? A function is a group of organized program statements that perform a specific task. A function is most times reusable and can be called from multiple places in a program. You get to understand these things while we start writing code. We start seeing them in practice. Now, when you write a program, you need to think about the input and an output. Sorry. The input is the data that the program needs to run, while the output is the result given to you back after the program is done running. For example, a program that calculates the area of a circle will require the input of the radius of the circle in order to do the calculation. So if you want to write a program that will calculate the radius of a circle, at least you need to give it a parameter to work with. We have already defined, I think the formula for area of a circle is, I think radius is equals to something pi r. I don't forget. Okay, yes, circumference over 2 pi. Yeah, radius is equal to circumference over 2 pi. That's the formula for area of a circle. So we can find the area of a circle if we provide the radius. With the radius, we can get the area using the value of pi, which is a constant, and then. But don't worry about the mathematical analysis I'm giving. It's just for you to understand that most times a program will need an input from a user for it to be able to run some logic and give you output. Okay. In order to write a computer program, you need a programming language. Right. So it's not about programming. What do you even use to program? What is programming? What do you use to do? How do you even achieve this programming thing that we're all excited about? That's where programming language comes in. Now, what is a programming language? The programming language can be defined as annotations used to instruct the computer on what to do. Programming language serves as a middleman that translates instruction into machine codes. Machine code are zeros and ones, and that's the language the computer understands. So programming languages serve as interpreter for converting languages into computer language called machine language. That might be a little bit confusing, so let me explain a bit. Imagine where you have a friend who does not speak English. Let's say the person is Spanish and speaks Espanol, and then the person is trying to communicate to you who is a non-Spanish person. Obviously, you won't understand, right? So you need a translator, someone who understands Espanol, to explain to you what the person is saying in Spanish. How do you do that? You either find a translator or however you want to do it. But the bottom line is there needs to be a translator. What does the translator do? Translator is because the translator understands the Spanish language that we're talking about here. You don't understand it, but the translator understands it. So when the person now speaks its language, the translator will now translate it in English for you so you will understand. The same way it works with programming languages. Do you understand? the the language a computers are very dumb, like they don't know anything. They only do what you ask them to do. Forget how complex they are. The complex is how we is the information we've given them over time. So it is the language computer understands zeros and one, binary numbers. That's what they understand. So for you to write a program and for computer to understand it, sorry, for you to give a computer instruction to do something and for the computer to understand what you're actually saying, it needs an interpreter, and that interpreter is the programming language here. The programming language is then what will convert whatever it is, the instruction you want to use. You can type this programming language that gives you more like a human readable way of writing instructions to the computer. Normally, you're supposed to write this instruction in zeros and ones, but because not everybody is a math genius, do you understand? And there's no, imagine if we are to come and start writing binary number, doing binary logic and algebraic simulations and all this type of complex mathematics just to be able to tell a computer to write a Word document for us. That can be very, very frustrating. Do you understand? So in order to not be, going round and round the circle and having like computer is never going to be innovative if it were to be like that. So people now said, okay, why don't we create something, a language that this thing can understand, like a translator that this thing that can help us translate whatever it is we are trying to tell the computer to do. Sorry about that. Hold on, please. Okay, so Samuel, I had a complaint. Some people say that they are not being allowed into the meeting, so please try and be admitting them. Okay, so I believe I'm still on track. Can anyone hear me? If you can hear me, raise your hand so I will know that you're hearing me. Okay, there's response. Okay, so that's good. All right, back to where we are. So we are talking about zeros and one, the language the computer understands. It is called machine code or machine language. Machine language is the zeros and one. The code is still the zeros and one. These are what computer understand. So these scientists came about and said, okay, let's find a way so that when we put in some human readable formats, you understand, some characters in a readable way, in a human readable way, then the computer can understand it. Then we can write some kind logic and do some kind hardware configuration that can help us interpret this English language in different formats, and then it will now translate to zeros and one, which the computer can understand. That is how programming languages were created. The first people that wrote programming languages were actually female. They were using punch cards. They use punch cards and like something like this Habakkuk calculator that was used in those days. They are punch cards. There's a way they use those things in describe. They use different characters. There's a way they used to do it, in those days. So after they have done, there's an instrument they use called punch card. After they are done using the punch card to create the instruction, they will now start installing, feeding those punch card into the computer, which can take hours and hours for even to impute stock more of the computer, even running it and then all that. So but that was real stressful. That was why programming languages were created. And then when it is now created, we can now write programs today, and then the computer can understand it, even though it is not zeros and one. I believe that's a bit clear. Now, there are types of programming languages. Basically, there are two types of programming languages. We have high-level language and we have low-level languages. So high-level language tends to take the form of a human language. It is usually readable and close to the English language. High-level languages are built on low-level languages just to make things easier for programmers. Examples of high-level languages are C++, C#, and Java. All right, so we have the low-level language, which is another type of programming languages. These are closer to machine language. They are hard to represent in a human readable form. Not that they cannot be represented, they are already represented, but just that they are a bit harder You understand? They are faster and they are fast to execute. I will explain that later because it's closer to the machine language. It does not take much work to translate to machine language. These languages are more closer to. It does not have plenty English. It does not speak plenty grammar. That one you don't have plenty English words there. It's just translated to you in machine language, so it's very low, closer to machine language. An example of it of those languages are assembly language and C language. At least I did assembly language sometime back then in school, and it wasn't funny, my brother. It wasn't really funny. That language was hell. I hated it so much because of the way it's not just fun to write. It doesn't make sense. Sometimes what you write doesn't make sense. So, but just because it is way low, it is like low level. Sometimes for you to declare a variable, you can say go to. Imagine for you to declare a variable, you say go to var. Let's say man. The name of the variable is man, and then you come and then for you to reference that variable, the thing is just full of shit. I don't really like it. So that's the reason why people see programmers, the ancient day programmers saw that these things are not going to help us, so we need to find a way to make these things easier. And then there has been innovations in programming languages. And then before we get to the IDE part, and then more type of programming languages were now created called the scripting language. So they are not included here, but it's not part of the core programming language. These are the major core programming languages. Then we have the scripting languages. The scripting languages are the modern day or the 21st century programming languages. These programming languages are written on top of the high level languages that we know. Like I said, the major high level languages that are there that have been there for years are C++, C Sharp, and Java. These three languages have been the ancient day language that have been built so far. And Fortran, yes, Fortran too, but Fortran is now obsolete. Nobody uses Fortran anymore. Fortran is just full of mathematics. Like if you don't know maths, you cannot use Fortran. I so much hate that language. So but it's no longer it might be in existence, I don't know, but people don't really talk about it. So but these three that I gave here are the mother of all programming languages. A lot of modern languages that we see today are built on top of these things, like JavaScript was built on top of C++, and then C++ was built out of C Sharp was built out of C++, and then Java is on another level. Java is on its own, but Java can trace its roots to C also. Do you understand? So C Sharp now gave birth to ASP.NET that Microsoft is using. C Sharp also helped Microsoft to create F Sharp. C Sharp also helped Microsoft to create some other tools like it was JavaScript. JavaScript was built on top of was gotten out of C++. PHP is also a scripting language gotten out of C++. And these languages are all scripting languages. Python too was gotten, I think, out of Java or C++. I can't really remember, or C, either C or C++. But Python is a high-level language also, but it's not a core high-level language. It is a scripting languages. Scripting languages, different between high-level languages, the one you're seeing here, and scripting languages. And scripting languages help to, like, they are built, firstly, they are built on top of the high-level language you're seeing here. Secondly, they are interpreted language. They are not compiled. Thank God that brought me to this part. It's really important we get to know this part. Excuse me, I'm calling. Okay, so sorry about that. I believe you all can hear me. All right, so
I can hear you, sir.
yeah, so um sorry about the whole thing. I'm just trying to manage a lot of things at the same time. Okay, back to business. So I was describing scripting language, the difference between scripting languages and high-level languages. These high-level languages are compiled languages. What that means is that first of all, they need to run and be compiled before you can use them. For example, If I'm to write a code or a piece of software that would what's it called? Maybe let me give you an example. Let me use Microsoft Excel for example. When it was built, the reason why those days in the early 90s and early 2000s this software came into be, before then we didn't have these mobile applications that we have now. We don't even have this online version of Google Docs that we use these days. These are core software that were built into desktop applications. What we have majorly are just basic desktop applications. And how? Because they are compiled. They are being after they are written, the bugs are corrected, the errors are fixed. They are now compiled, and once they are compiled, we can compile them into desktop applications. And when it is compiled, you don't need to compile them again. They can run anywhere. You can put them on any platform and they will run because they have already been compiled into machine code. So anywhere you are moving that file to is no longer that text, that English language you wrote there. No, it's now zeros and one. So that is why whenever you put it on any software, any operating system, it will run. If you bring your Microsoft software disk now, insert it in your computer and you run it and you install it. After the installation, you've bundled the whole code, all the binaries, all the zeros and one have been compiled and downloaded to your operating system. So when you start using it, you don't need to connect to internet, you don't need to do anything. Immediately you are typing on Word document, it is processing and everything is fast. You think that is when the whole thing was done. Everything has been done and compiled and packaged for you. Computer is just waiting for your input. Any input you give it, immediately it gives you response immediately. It's not that moment you are typing that and that it is interpreting it. No, it is already interpreted, compiled and packaged for you. That's for high level languages like C++, C#, and Java. But when you come to scripting languages are how do I even put it? Because they are built on top of compiled languages, they are interpreted, they are not compiled. What that means is that they are feeding off of compiled code. So if you're writing a program that will do something with JavaScript now, what it means is that there is already a JavaScript translator or transpiler. Yes, a JavaScript transpiler is called transpiler. Don't worry about the term. Transpiler is just a piece of software that translates a particular programming language into another programming language. That's what it means, transpilers. So it transpiles that JavaScript code into C. And that C has already been compiled into a machine code on your laptop. So immediately you are typing or you are running that script, let's say JavaScript code now, and you just get into error. JavaScript will Kukuma tell you immediately there's an error. But if it is on Java, the code needs to compile first before it will detect an error where you made a mistake, maybe a logical error or syntax error. It will detect it and tell you, okay, there's a mistake here, and the code will stop running, will start fixing. But on JavaScript, as you are typing your code, somehow there's tool that is even helping you to even debug some errors on the go. Do you understand? That is because some of the functionalities this scripting languages can perform are already coded in their mother language like C or C# and compiled into machine code. So you are just adding additional feature onto an existing programming language. Do you understand? That's what it is. It's just a sugar or how do they even say icing to the code or something. Those are big. I don't know how you guys say it, but it's just like a subsidiary language that is created to help the main language to perform some tasks and solve some problems. Do you understand? So that was how scripting languages were created, and all of a sudden scripting languages in this 21st century became a thing that with scripting languages you can even create desktop applications. This was not the case before in the early 2000s. No. But now we can use scripting languages to even create desktop applications. We can use scripting languages to even create server applications, web applications, mobile applications. Before it was not like that. So scripting languages now, even today, are confused to be programming language, but they are not core high-level programming language. But they are still high-level programming language. But you should. I'm only explaining this so you will know the difference between the two. You understand? But they are all assumed and said to be high-level programming languages. So that's that for now. If you don't understand, ask me later. Thank you. So how do you write code? Codes or programs are written using an IDE. What is an IDE? An IDE is an integrated development environment. There are many. Why is it integrated? Is because in an IDE all the necessary things you need to compile a code is in there. When you are done writing your Java code, the processes, the hardware tools, the whole thing that will make it to run is there on the IDE. So immediately you are done writing, you click on run, it will now start compiling your code before it will give you an output of what you've written. So there are many IDEs out there. Back in the days before scripting languages became popular, and people started using text editors. We had IDEs like NetBeans, Visual Studio, and IntelliJ. I personally used this NetBeans when I was learning C#. I was not able to install Visual Studio, so I looked for an alternative. There was one other compiler I installed that time back then. This NetBeans was like the goal then, because Visual Studio used to give problem. If you are not even on Windows, you cannot use it. It's a very big, massive IDE that helps you to write basically C# codes. You understand? Because Microsoft built all its technology on top C# as a language. That's anybody that is doing C#, they assume you to be a Microsoft person. Yeah. So then, back then in those days, if you don't have Visual Studio, you cannot even code C# without. Okay, you can code C# without Visual Studio with other IDEs, but if you really want to enjoy C#, Microsoft made it so sweet with Visual Studio. So it was a thing back then, and people were just using it. It was fun though, but it used to give problems in installation. But NetBeans helps you to not just write. Just with NetBeans, you can write Java, you can write you can write what's it called, C++, C#, and Java as well. Yeah, those three. So you can write the three in NetBeans. Even in IntelliJ too, you can write the three languages there. Just that Visual Studio, you can write the three languages there, but it was specifically sugar coated for C#. So C# developers love to use it then. So, but one problem with this IDE is that they are heavy software tools. They are really heavy. Sometimes your system might not even have the requirements to carry them, and you have problem installing them. I mean, if you cannot install them, you cannot even run your code. You cannot even write your code. So over the years, these are even what gave rise to the development of all the scripting language you are seeing today: JavaScript that runs on the browser, PHP, Python, and all that. So as time goes on, IDE, now people started developing lightweight IDE that can help, that doesn't require all these plenty materials, all the plenty computer resources for you to run your code. That was how text editors came into being. And then we have something like Sublime Text, we have something like Visual Studio Code. Visual Studio Code is just like a subsidiary lightweight of Visual Studio. You understand? But it was not owned by Microsoft. It was just recently that Microsoft bought it. It was open source, created by the people that owned them. What's it called? I think Git. Yeah. But recently Microsoft bought it and they now owns it now. So, but it's open source. Even till now, it's still open source. Open source means it's free. It is not paid. So that's how IDEs were and what they were used for. So just used to compile code, and there are some other small functionalities that are embedded into IDE that make writing programming with them very comfortable. It can help you detect syntax error you make with language grammar, programming grammar. There's what we call programming grammar. When you are not writing the program in the right rules, you are missing out some rules. Maybe you didn't add semicolon or something. These are syntax error. So the what's it called, the IDE helps you to detect that instead of waiting for when you now compile for you to tell you. That's the beauty of it. But thank God today, because of scripting languages, you have other text editors. These are just lightweight IDEs. So I believe that's that. We now have programming grammar and patterns. What is programming grammar? Let's say that learning a computer language can be very similar to learning a real language. A programming language have a set of rules and patterns you must follow when writing that language, just like a real language. You know, when you are teaching English in school, we have verb conjugation. Even in French, in German, you have verb conjugation in different languages, and we have the pronouns, we have the adjective, and how to use them, the verb, and all that. Same goes with programming, just in a different way. So in computer science, the rules and pattern of writing programs are called syntax. Syntax is defined as a set of rules one must follow when writing code in order for your code to run correctly. These rules have to do with maybe how you type out certain functions, how you put what you put at the end of at end of each line of your code. Also note that breaking any of these rules guiding a language will result to an error. You understand? And once there's an error, your code cannot run. So I think that's that. Uh, I think we would be jumping right into the coding part. But so far, so good. Is there any question? Hello? Yeah, good evening. Go ahead, Victoria. Okay. Mm, yes. Is that your yes? Is that your question? So far, so far so good. My question to you is: all these ones I've been teaching, are you understanding them? Because if you don't understand these ones now, the web development part is going to be very difficult for you. Thank you, Gloria, but that's not how we're going to do it here. I believe you went through the curriculum, so we're going to follow the curriculum, and I have my reasons for that. Does anyone have any other question? Okay, we have quite a lot of questions. Okay. Yeah, I'm strong. Go ahead. Good evening. Yeah, yeah. Okay. Those are, yeah. To answer your question, I'm strong. Those are high level languages as well. They are scripting languages. You understand? You can they are subsidiary of high level language, but you can also call them high level language. And they are also scripting languages. Yeah. Does anyone have any other question? Okay. Let's start with Florence. Okay, hold on. Let's hear from Florence first before you can make a contribution. Florence, are you there? Yeah, good evening. Yeah. C is a low level language. Yeah. Okay, so Joseph, please, your contribution, please, before we go to the next person. Okay. 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 Are you into construction? Okay. I don't really like that language. It's full of mathematics, anyways. But that's fine. Um. mm, Who else? Mr. Uge, can you ask your question? Okay, well, your hand is raised up. That's why I pointed. Friday. Yeah. Yeah. Good evening. Go ahead. Yeah. No, no, no. Java is different. JavaScript is a different thing from Java. Java is a high-level programming language, like so high level and a very root base. So JavaScript is far from it. Even JavaScript is not even built on top of it. JavaScript is built on top of C++, either C or C++. Yeah. Okay, go ahead. Okay. Okay. Before C used to be a high-level language. Do you understand? But now it is being classified as a low-level language because it is being classified as a low-level language because it is used after assembly language. It is the next language after assembly language that is closer to machine language. And because there actually has been a lot of developed high level languages recently. Back in the days, we don't have almost a lot of programming languages that we have right now. The scripting language that we have right now that can do a lot of more powerful things. So that is why it is now currently categorized as a low level language after assembly language. You understand? Then from C++ upwards, C++, C Sharp, Java, all of them are high level language. As of 1990s and 2000, C was being classified as a high level language, but now you can't classify C as a high level language. Although most high level languages we see today are built on top of C. Yeah, so that's the answer. I don't know if you are okay. All right. Okay, so if can you ask your question, please? Mm, mm. Yeah. Yeah, Python is a high level language that is built on top of C, although it's classified as a scripting language. Do you understand? But it's a high level language as well, built on top of C, but it's not among the core base high level languages. Do you understand? Yeah. So yeah. So that's that for Python. Majority of these languages are built on top of C. Even PHP were built on top of C. So uh, there are some other recent languages that uh, were built on Java and some other C++ and the likes. You understand? There are so many programming languages even currently that are built by Microsoft that are sitting on top of C Sharp. So it's just for us to know them, and then basically what we're going to be using in this tutorial is JavaScript. So I think that's it for question. Let's go over to the next phase, which is coding. So before then, I believe you all have installed VS Code on your laptop, and then you have what's it called? You have VS Code on your laptop, and then you have installed Node.js, right? So that's basically the tools we're going to be using right away. So we're going to be jumping right in, but I think not on this meeting. We're going to share a link on the group right now for the class for us to join. So just get your system set up and then join the meeting using your laptop. So I'll be waiting for you guys on the other side. Thank you.